right, next we're going to talk about inverse variation. With inverse variation, we follow, or we use the equation y equals a divided by x. So with direct variation, remember we were multiplying, now it's the inverse, so instead of multiplying by x, we're going to divide by x. This is our first look this year at rational equations, where we have the variable in the bottom or the denominator of a fraction. The one rule for this, of course, is that x can never equal 0, because if x were 0, then we'd be dividing by 0, which is undefined. A is still the constant of variation. And sometimes you will see it instead as k. Our textbook uses a, but a lot of places will use k instead. So to tell whether something is direct or inverse variation, you're just looking, does it follow this pattern of multiplying a constant times the x or dividing by x? So for instance, y equals 3x, this is direct variation. Y equals x over 3, well, that would be the same as 1/3 times x. So this is also direct variation. Notice here the x is in the numerator of the fraction. We're not dividing by x. Whereas if we had y equals 3 divided by x, that is inverse variation, because the x is what's in the denominator. Also, sometimes you'll see it look like this, xy equals 3. Well, if we solve for y here, then we end up with y equals 3 divided by x. So again, look for this, because that is still inverse variation. Let's see. So if you are writing, that's too far. If you are writing an equation given a point, say you have x equals 5 and y equals 3, and you are told that they vary inversely, so we're going to use y equals a divided by x. So just like with direct variation, we're going to substitute in our x and y. So 3 equals a divided by 5. And then we're going to solve for a. So multiply by 5, multiply by 5. So we get 15 equals a. So now we can write our equation y equals 15 divided by x. Okay, I feel like this camera angle is really bad. I'm going to try to fix that. Is that better? See if that's better. Okay, all right. To check to see if data are inverse or represent an inverse operation, we can make a table and let's say something like this. So if this is true, then if we multiply these together, we should always get the same thing, right? Because thinking again, y equals a divided by x, which means x times y equals a. So if we multiply these together, we should always get the same constant. So 2 times 50 equals 100, 4 times 25 equals 100, 10 times 10 equals 100, and so forth. So yes, this is in fact inverse variation, y equals 100 divided by x. Now sometimes with real world data, it's not going to be quite so clean. So in the study guide, there's an example like this. And then it goes 545, 444, 376, 325, and 285. Okay, so for this example, we're going to go through that process. We're going to multiply our x and y, so 22 times 545, which is 11,990, and then we're going to do that for all of these. So 27 times 444 equals 11,990, or sorry, 88, and 32 times 376 equals 12,032. And 37 times 325 equals 12,025, and 42 times 285 equals 11,970. Now, again, real world data isn't going to be exact, but when we're talking about, you know, over 10,000, this is all pretty close. They're all around approximately 12,000. So we say yes, it does have an inverse relationship. Not perfect, but pretty good. Okay, and we're going to call it good there.